there could be some situation where long division can be skipped during the SAT. And that's in case the situation that we are having in front is connected with two important theorems. One is the remainder theorem, and one is the factor theorem. Let's start with the very first one. And here we are dealing with function, but in general, these two rules can be applied to any polynomials involved with a fraction or a division. The remainder theorem says that whenever we have a function, polynomial function, that is divided by a binomial x minus c, the remainder can be found by solving for f of c. Let's take a look at this concept. We have in a function, and this one is divided by a binomial with the maximum exponent to be 1. That means that whenever you have a situation like this one, we can find the remainder without doing the long division, but just by solving the function. Let me explain. Let's take this example. Here we have the question that asks, find the remainder of the function f of x equal x to the power 3 plus x to the power 2 minus 6x minus 7 divided by x plus 2. Now, since they're asking about the remainder and they're talking about division, we can think that we need to do the long division. But since the binomial that we are about to divide is a binomial that is exactly like the theorem that we want to see, instead of doing the long division, we can take that binomial and put it equal to 0. By doing that, we will find a value for x that is equal to -2. Instead of doing the long division, then I can take my function and solve for -2. In fact, if I do that, now I have to evaluate. So -2 to the power of 3 plus -2 to the power of 2 minus 6 multiplied by -2 minus 7 will give us something like this. Let's keep going. -2 to the power of 3 will be -8, and -2 to the power of 2 will be plus 4. -6 multiplied by -2 will be plus 12 minus 7. -8 plus 4 will be -4, plus 12 will be plus 8, minus 7 will be plus 1. That means that the function of -2 will give us a result of 1, which is our remainder when we divide that function by -2. Way easier, right? Simpler than we expected. That's a proceeding that we can use every time we have a situation like this one. We can just divide by, instead of doing the division, we can just solve the function for the value that that binomial will give us. However, I want to make something very clear. Here we're dealing with a function. Whenever we are dealing with a function, we will have a graph. In this case, we have a function with highest exponent to the power 3, so we will have this type of graph. As any function, whenever we solve that function by a value, the result will give us another value that will represent the y component of a coordinate of the graph. So when we solve the function for -2, not only 1 is the remainder where the function is divided by x plus 2, but that will be representing also the coordinate -2, 1, like we can see here in this case. So when we solve a function by the value that is represented by the binomial, we will find the remainder, but also a coordinate, okay? Since this is clear, now a question like this one all of a sudden will become very easy, because what the question asks? Well, the question says, the function f is defined by a polynomial. Some values of x and f of x are shown in the table above. What is the remainder when f of x is divided by x plus 2? Here, they want us to find the remainder for f of x when it's divided by x plus 2. Now, it's true, x plus 2 is the typical binomial that we can solve by applying the remainder theorem. So we can put that one equal to 0, and then we solve for x, and that will be -2. Now, we should just plug it in on the function. But there is a problem here. We don't have a function. They didn't provide it to us. And since this one is a type of function that we don't know, we cannot assume that it's a linear function. And so what do we do? Well, following what the question says, some values of x or of x are shown in the table above, which is that some of the coordinates of the graph from this potential function are given right there. And here we see that when x is equal to -2, f of x is equal to 2.5. Now, remember what I said before. This one represents our coordinate, of course, but at the same time, this is also the remainder when the function is divided by -2. So the remainder here will be 2.5. That's why the answer for this question is C. The answer to this question is given. All we gotta do is understanding the concept of remainder and remainder theorem. Another important theorem is the factor theorem. The factor theorem is slightly different because now it revolves to the fact that the binomial f minus c not only can divide my function f of x, but when it's applied on the actual value of c on the function, we'll get 0. So what's happening is this. Whenever we plug in a value for x of the binomial that is dividing the function, if the result is 0, that means that that binomial is a factor of the function. So let's say this. Find the value of a if x minus 3 is a factor of the function f of x equal x to the power 3 minus 11x plus a. If we understand correctly what we said before, first, this is a binomial with maximum exponent being 1. That means that we can just place this one equal to 0, and we can say that x will be equal to 3. But at the same time, since this question is telling us that that binomial is a factor, that means that f of 3 will be just equal to 0. Remember that coordinate 0, 3 are x-intercept. That's what it is when we are looking for factor theorem. And that should be also, that should ring also a bell regarding factorization and quadratic function. But let's go back here. Since we know that whenever we place x equal to 3, we will get that f of x is equal to 0. Now we can take back this function and say that 0 is equal 3 to the power 3 minus 11 to the power, then multiply 3 plus a. So basically what we're saying is that since we are placing here the value of 3 for x, f of 3 will be 0. And now we have only one variable, a. We can solve for it, right? Now, 3 to the power 3 will be 27. So we have 0 equal 27 minus 33 plus a. 27 minus 33 will be negative 6. We'll move it in the other side, and we will get that A is equal to 6. That will be our answer. You see? That's an application of the factor theorem. But let's see another problem. Which of the following is not a factor of the polynomial p of x equal to x to the power 3 minus 5x to the power 2 minus 4x plus 3? In here, we are looking for the case that is not a factor. So we expect that one of these binomial, when converted to a specific value for x, will not give us, as a result, px equal to 0. Now, this is a question that is potentially wasting time for us. Why? Because in theory, we need to solve for many binomials. So what I'm going to do is this. Instead of going by order, I'm going to go by similarity. B and D, in fact, are very similar. So I'm going to solve first for B and then for D. If I solve for B, for example, right, that means that I need to take that binomial, put it equal to 0, and now I know that x will be equal to -1. That means that I need to apply -1 on my function. If I do that, I will get 2 multiply -1 to the power 3, minus 5 multiply -1 to the power 2, minus 4, then multiply -1 plus 3. All that will tell us that -1 to the power 3 stay negative, so that's going to be -2. Minus 5, because -1 to the power 2 is just 1. -4 by -1 will be 4 plus 3. All these at the end will be 0. What does it mean that? Well, it means that this binomial is a factor of this function, because the result when we apply x equal to -1 is equal to 0. That means that B is not the answer for this question. Let's try then D. If we try D, that means that x minus 1 is the binomial that will be placed equal to 0. And now we have x equal to 1. Since x is equal to 1, P of 1 will be just those values. And that's it, because each of these exponent for x is going to be at the end equal to 1. So that's what it's going to be. It's going to be 2 minus 5 minus 4 plus 3. And all these will give us that P of 1 will be equal to -4. -4 is not 0. That's a number. That means that x minus 1 give us a remainder, not at 0. So D is the answer. I hope all of this is clear, because now we need to add a layer regarding the factor theorem. So far, we have solved all questions where the theorems was applied because the question was asking about remainder theorems or factor theorems. But there are sometimes other questions that are not asking us that right away. For example, in the polynomial g of x defined above, c is a constant meaning a number. If g of x is divisible by x plus 1, what is the value of c? Now, the question is asking us to find c. We got a problem. The problem is the following. On the function given, we have too many variables, x, g of x, and c. It's tough to solve it without having a coordinate for that function. However, here the question is telling us that g of x is divisible by x plus 1. What can we do for that? Well, there are a series of statements that we can use to solve questions like this one. For example, this one right here. When the question is telling us that the function is divisible by a binomial, we can assume that that binomial will be a factor of the function. So we will take this binomial x plus 1, and we put it equal to 0. And this one tells us now that x will be equal to -1. Well, when x is equal to -1, now g of -1 will be equal to 0, giving us the coordinate that we were missing. Because now we can apply this coordinate on the function, and we will have 0 equal negative, then multiply -1 to the power 2 minus 6, and multiply -1 plus 5 minus 4, then multiply -1 minus c. As you can see, now this function becomes just an equation with one variable, and the variable is c, and we can solve for it. 0 equal -1 to the power 2 is 1, -6 by -1 is 6, plus 5. All these will be 12 multiplied by negative, it's going to be -12 plus 4 plus 4c. -12 plus 4 is going to be 8. We move it in the other side, and we have 8 equal 4c. So here we solve for c, and that one will be 8 divided by 4, which is 2. The question all of a sudden becomes a joke by understanding the application of the factor theorem. Because again, there are a series of statements that we can use to solve it. What are those statements? Well, we just went over one. Whenever the question says f of x is divisible by x minus c, we can just use the factor theorem, assuming that that binomial will give us, as a result of the function, equal to 0. They can also say x minus c is a factor. That's clearly a statement of the factor theorem. But they could say also that, I will do it, they could say also that c is a solution to the equation f of x equal to 0. And that is another statement of the factor theorem, right? Because when c is a solution of the function of x equal to 0, that means that it's a factor. That means that f of c is equal to 0. And as we said before, when we have f of c equal to 0, that means that we have a coordinate c, 0, and that one is an x-intercept. And that's why if they say to us c is an x-intercept of the graph f of x, that is just referring to the fact that f of x is going to be equal to 0, which is the factor theorem. Lastly, c is a 0 of f of x, and c is a root of f of x. Those are all synonyms of x-intercept, which means that f of x is equal to 0, which means x minus c is a factor of f of x. Those are all statements that we need to remember, because then we can apply them for the factor theorem in question like this one. Let's do last question together. In a question like this one, which of the following expression is equivalent to the polynomial fraction right there? Now, the instinct by looking at the possible answer is to do the long division. But notice that all of these are remainder, and all of them are different. Instead of doing the long division, let's solve this one with the remainder theorem. That means that x minus 3 can be put in equal to 0. That means that x is equal to 3. Then let's take the polynomial on top. You see, that's not a function, that's just a polynomial, but we can apply the remainder theorem, and that will be 3 to the power 2 minus 2, then multiply 3 minus 5. 3 to the power 2 will be 9 minus 6 minus 5. That's going to be -11 plus 9 minus 2. My remainder will be -2. And look, on D, we have the remainder -2. So this is the answer. It took us less than 30 seconds. Now you do it and let me know how it went. Okay? Have a good day. Bye.